So similar to the last problem, with the 2 on the other side, this isn't going to factor. So when I bring the 2 over and I rewrite it as 3 sine squared of theta plus 2 sine of theta minus 2 equals 0. Often when I factor it, I just think about it as 3x squared plus 3x minus 2 equals 0. And if I try to factor this one, 3x times x, 2 times 1, the 2 either has to go here or here. If I put it over here, I'm going to get 3 times 2 is 6. And that's just not going to lead to that 3 in the middle. I could switch those. I could put the 2 here. And then depending on how I put my signs, I'm either going to get a positive 1 or a negative 1 in the middle. So this thing does not factor. So if it doesn't factor, what do? I could complete the square. I could use the quadratic formula. Generally, we're just going to use the quadratic formula. So for the quadratic formula, I have a equals 3, b equals 2, c equals negative 2. Usually for the quadratic formula, we write x equals, but here my x is really a sine. So I'm going to have the sine of theta equals, and then use my formula, negative b plus or minus, so let's actually put in the numbers, plus or minus the square root. And here I usually slow down to be careful, b squared. So 2 squared is 4. I can do that in my head, but I'm going to slow down here, minus 4 times 3 times negative 2. Negative times a negative is a positive, all over 2a, 6. So here, what do we get? We get 4 times 3 is 12, times 2 is 24. 4 plus 24 is 28. So I get negative 2 plus or minus the square root of 28 over 6. And then can I reduce this? It's often worth trying, but it's not always necessary. 28 factors as 4 times 7, right? So that right there, the square root of 28 is really the square root of 4 times the square root of 7, which is twice the square root of 7. So I can clean this up, negative 2 plus or minus 2 square roots of 7. And since there's a factor of 2 in both parts of the sum or difference in the numerator, I can pull that out. So 2 times negative 1 plus or minus the square root of 7 over 6, and 2 goes into 6 3 times. All right, so what we have now is the sine of theta is equal to negative 1 plus or minus the square root of 7 all over 3. So I have 2 different versions of this, right? The plus is one, the minus is the other. So we break those down next. Sine of theta is negative 1 plus the square root of 7 over 3. We need to get the approximation of that on the calculator. Or sine of theta is negative 1 minus the square root of 7 over 3. So let's check those on the calculator before we apply the arc sign. All right, let's clear this. Okay, so I need fraction, so divide negative 1 plus the square root of 7 over 3 gives me 0.5-ish. Okay, that's good. And then the other would be fraction negative 1 minus the square root of 7 over 3, negative 1.2. Now, about negative 1.2. So let's say negative 1.22-ish and 0.55-ish. So this one right here is about 0.55. We'll use the exact number on the calculator in a moment. This one right here is negative 1.2, no, I forgot, 22. And before I proceed, just thinking about the unit circle for a second with the sign. On the unit circle, the sign is a y value. And remember, this is the unit circle. And so I'd be looking for y equals negative 1.22. That's down here. There is no point on the unit circle related to this one, and that's going to happen sometimes. There's solutions don't always work out well. So this one is not going to work out because there is no y value that the sine of an angle is going to be equal to. Doesn't exist. You could double check by asking the computer what's the sine inverse of negative 1.22. And we should get something interesting. Let's give this a name here. Let's call it B. And if I ask what is, we can bring up the sine inverse or type arc sine of that number B, I'm going to get an undefined because that it's the sine inverse doesn't know anything about that. So sine of inverse can only handle numbers between -1 and 1, and it's only going to output angles between negative pi over 2 and pi over 2. This isn't in that range, so that right there is not a solution. So my only solutions come from that other root there. So if you get, in a problem like this, if one of the values from the quadratic formula is bigger than 1 or less than -1, it doesn't work out, throw it away. So my only solution is related to this one right here. So I'm going to get theta is equal to the arc sine or sine inverse of that -1 plus the square root of 7 over 3. We'll get an approximation of that. And remember, so let's see, positive 0.55 is about up here. So the arc sine just told me that point right there and this angle right here. Symmetry of the circle tells me there's another one over here with that y value. And so I want to know what that angle is. And that angle is always pi minus what the arc sine says. So if that one's theta 1, theta 2 is going to be pi minus theta 1. So I get two basic solutions here, and then I could just add 2 pi or subtract 2 pi over and over again to either of those. So let's look at the graph, see if it confirms that. Let's see, we'll leave that there. Let's call this solution A. And then graph our function, the left side, 3 sine squared of x plus 2 sine of x. So same function we looked at in the previous example. This time I want to know, when does it meet up with y equals 2? And think about looking with from 0 to 2 pi. So I'm going to graph x equals 2 pi to show the first, not 2i, 2 pi. There we go. All right, so how many solutions do I have between the y-axis and then x equals 2 pi? I have 1 there. So that's that. Ooh, wait a minute. How come I'm getting a different number here? Did I mistype something? 0.58. I was thinking it was 0.55. Okay, I have an error somewhere. Interesting. And the other one here, 2.56. I never calculated the other one, but there are only two basic solutions. Okay, so where do I have an error? Did I mistype my function? 3 sine squared of x plus 2 sine of x. That looks right. Y equals 2. That looks right. Okay, so I must have an error in my arithmetic over here. So let's see, 3 sine squared, let's troubleshoot this, plus 2 sine equals 2, that's what I graphed. Subtract the 2 over and I get a is 3, b is 2, c is -2. Negative b plus or minus the square root of b squared times 4ac. That looks okay. 4 times 3 is 12, times 2 is 24. 24 plus 4 is 28. So you guys chime in if you see my error. I don't see it yet. Square root of 28. 28 is 4 times 7, so that's twice the square root of 7. Factor out the 2. Interesting. I don't see the error. There's an error somewhere. Oh shit, I know where the error is. I forgot to take the arc sign on the calculator. This right here is that fraction. So my number A here isn't the solution. I want the arc sign of that. So let's put the arc sign in front there. I wasn't finished on the calculator. There it is. All right, so the work on the paper was absolutely right. I just didn't finish it on the calculator. So first solution, arc sign of that fraction from the quadratic formula, again, is that first point right there. And then pi minus that is this one over here. Double check that one. So my other solution, B, equals pi minus the first solution I called A. And I like naming things in Desmos so I don't have to retype that again. Retyping gives me a chance to make a mistake. And so the 2.56 was that other X value here. Cool. Let's try another.